Okay, so on this kind of a problem, um, we're going to recognize that, just like we learned in Math 95, that we can factor out a -1 from that -80. And there's a perfect square that divides into 80 called 16. So the square root of square root of 16 becomes 4. The square root of -1 becomes I, and the square root of 5 is square root of 5. So remember that I equals square root of -1, and everything in this section is derived from that truth right there. Okay. Uh, So on these problems, you're always going to peel off the -1, and that always becomes the I. And then whatever's left over, just like the old days, look for a perfect square like 16 that divides in. And simplify it. Now on these, when you're multiplying and dividing square roots of negatives, first things first, pull the i's out. Okay, now there are certain problems or math problems, where it's not going to make a difference if you do or you don't. Okay, let me find a better one here. Yeah, it won't make a difference, but on some of them it will. So let's take a look here. So we're going to pull out the I, pull out that square root of -1 on the top and the bottom. And then we could say, hey, well, first of all, the i's will cancel, just like a regular I or a regular x. And then I can do square root of 120 over 10, which is square root of 12, which is square root of 4 times 3, which is 2 root 3. And then that's as far as we can take it. Okay. And there's no I left over. Now, in the second one, in the first one, you may have noticed that if we had not pulled the i's out right away, and we just did -120 over -10, we still would have ended up with +12, and nothing would have changed. So on this one, it would not have made a difference. On the second one, we pull out the i's. Okay, and then I could do square root of 144 times 64, but I already know what those individual square roots are. They're 12 and 8, and so that's cool. Now, what about I times I? What does that do? Well, remember, everything comes from I equals square root of -1. So if I square the I so that I can find out what I squared looks like, I got to do the same thing to both sides. But squaring and square root are opposites of each other, and they cancel, so it's just -1. So we get a factor of -1. Now, if we had not pulled the i's out at first, we would have missed that. We would not have gotten that extra factor. Okay, so the answer is -96, not +96. So pull the i's out first. Now, when it comes to adding or subtracting complex numbers, I don't spend a lot of time on it because it's exactly what you did in pre-algebra, to be honest. It's just like terms. So -1 minus -4 is the same thing as -1 plus 4. So that's 3. Then 3i minus 2i is a +1i, and the problem is done. And that's all you do. Okay, so when it comes to adding and subtracting, you don't even have to think about the fact that you're working with complex numbers. However, when you multiply, yeah, then you got to worry about it a little, not much. Okay, so we multiply like normal. So 4 times 3 is 12. 4 times 4i is 16i. Minus 4i times 3 is minus 12i. Let's do this one. minus 4i times plus 4i is minus 16i squared. Okay, so now we can, combine like terms, okay? So 16i minus 12i, I think we can all agree that's a positive 4i. And then remember I squared, yeah, that's still negative 1. So I can replace I squared with negative 1. So I'm going to get 12 plus 16 is 28, and then still plus 4i. And then that is as far as it will go. Now, before I forget, there's something you might want to know on your calculator. Yeah, there's this letter I. If I go alpha I, that's just regular old letter I, no big deal. Okay. But right above the decimal point, if I go blue decimal, this little piggy right here, this lowercase I, that is the I that we are interested in, that we're working with. Now, in order to use it, it helps if you go to mode and then select A plus BI with the enter key. Okay, and then this problem that we just did would look like this. Give me a second, I'm slow, but I do forward. And I still get 28 plus 4i. Pretty sweet. Okay. So make sure you can do it by hand and calculator. And then we'll get along just fine. Okay, so when you divide by complex numbers, it doesn't even look like division. In fact, it looks more like rationalizing the denominator. Remember way back when we had things like 7 over 2 plus the square root of 3 or something like that. And we'd say, what do you multiply by? Well, multiply by the conjugate, 2 minus square root of 3. Just change the sign to the opposite. And then, of course, do it to the top as well, and then multiply it out, and then you don't have a radical anymore. Okay, well, remember, that's just square root of negative 1. Therefore, there's a radical in the bottom, and therefore we handle it the same way. So we're going to go multiply the top and bottom by the conjugate of the bottom. So the same thing as the bottom, just change that middle sign. Okay. On the top, we get negative 25 minus 30i. And just like with rationalizing the denominator, it doesn't matter what the top looks like. It doesn't matter if it gets messy. Just make sure you get the bottom all cleaned up. Okay. In the bottom, it turns out that when we go multiply, 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 and do all 4 of them, you're going to get 5 squared minus 6i squared. Okay, because if you use the difference of squares factoring technique, then and you start here and you factor it, well, you get back to there. So I'm just using that information for Math 70. Okay, so then I get negative 25 minus 30i, and at this point I just got to tidy it up. So I get a 25 on the bottom, and then I get minus 36. The I squared gives me a negative 1. So let's see, so it'd be 25 plus 36 is going to be 50, 61. Well, 61's prime, so nothing. You can't factor anything out of it. Therefore, you're not going to be able to cancel anything. Therefore, you're done, except I believe that Alex wants you to write the answer slightly differently. Okay, so Alex just wants you to say, all right, 61 goes into negative 25, so you got negative 25 61st. And then it goes into the second term, minus 30 61st. And the reason why Alex wants you to do that is because it's traditional when you do stuff like this to say, hey, this is my answer, this complex number. Again, complex just means the answer comes in two pieces. And negative 25/61, that's the real part of the complex number. The imaginary part, the part multiplied by I, is negative 30/61. And then that way you can explicitly see the real part and the imaginary part of the solution. I don't really think it's a big deal, but that's the way it'll be on the test and in the homework.